Anyway, but yeah, lovely to be here. Thank you very much. I'm going to press my timer. So my name's Elaine Toogood. I'm Director of Architecture and Sustainable Design at the Concrete Centre. And I'm going to be talking about GRC in terms of how it can meet and can develop to meet the requirements of architecture today and in the future. I'm an architect. There's going to be very little technical here and lots of pictures. It's the Architecture Day. That's what you'd expect, isn't it? So if you don't know who the Concrete Centre are, we are the central technical and marketing hub for concrete in the UK, so principally UK focused, but most of our information is all online. We provide a lot of resources, technical advice for construction professionals to assist them in their use of concrete. We're not the place to look for the GRC guidance. We leave that to the GRC experts, and so look at the GRCA website. Great, loads of information there. But we do provide a lot of information with regards to inspiration. One of those publications, and all of the stuff pretty much is free to download from our website. And look at that, concretecentre.com. Lots of resources, webinars. Concrete Quarterly, we're very delighted to be the current custodians of this magazine, technical magazine, that's been running since 1947, and every single edition is available free to download on our online archive, and it includes lots of great GRC. And in fact, as it happens, the current edition, produced this week, has GRC on the front cover, a very lovely facade here in London. So there we go. As if by magic, these things get coordinated. So do have a look at that. And of course, this is one of the platforms for a lot of our international inspiration work. As I said, the reason why we are UK-based is we're part of the Mineral Products Association, which is the trade association for most of the stuff that comes out of the ground within the UK. But of course, that includes all of the cement manufacturers and a vast number of the concrete manufacturers. Some of them are glass-reinforced producers as well. And that cement bit and the aggregate bit is obviously key components with the making of GRC, as it is concrete as well. And that's what I'm going to be talking about today in terms of the needs of architecture to understand much more about what it's using and the credentials of the materials. And of course, spoiler alert, I'm going to be talking about sustainability. You heard a lot about that today, but I'll be talking about that. So, glass-reinforced concrete, I think you know all what it is. I don't need to repeat that. But you know, not that dissimilar in some respects to concrete in the sense that there's a binder, Portland cement, activated by water, the use of minerals. But of course, what's different and that's fundamental to its performance is fibers being used instead of ordinary rod in reinforcement. So sometimes it can look like ordinary concrete, if there is such a thing, what you'd expect it to look like this lovely example. You will see peppered throughout my presentation lots of examples of the shortlisted for the awards, because I was honoured to be one of the judges, so I thought I had to give them as much airing as possible. Another lovely one here. And of course, it looks like concrete. It's using grey cement, that's what's giving it its colour, but behind that, it's hollow. You wouldn't know that to look at that. Obviously, a big advantage in this temporary facility, because it was this temporary show, because it could be lifted up and moved. And it is that ability for GRC to be able to be thinner, which brings with it a whole range of other benefits. And of course, it doesn't have to be grey. If you're using the white ingredients, you can make white GRC or any other colour that you like, pretty much, which is what, for us as architecture, the potential for the creativity and the expression is one of those really great advantages, not only big, and also what it's doing from a mineral point of view. Now, I was very pleased. I was in Dublin yesterday, and the day before that, I went to a precast factory close to Dublin, and I managed to snap one of these, picture of one of my favourite bit of panelling of GRC in London. It was still sat in the yard, even though it was built a few years ago now, still looking brilliant, as part of the Tapestry building, not too far from here at King's Cross. And what I love about this example, of course, is not just the colour, but also the other thing that GRC can bring to architecture, and that's its ability to take form in terms of pattern and shape, the ability to be able to mass produce repetition of craft, which used to be, painstakingly produced and need to do it. Now with new techniques for form making, or you only need to make the mould once potentially, but you have so many opportunities, and that ability to be able to then create texture, but also then produce some surface finish treatments to be able to express a bit more of the minerality of that surface is certainly what gets me very excited in the potential of the use of GRC within architecture. And a lot of one of the things about GRC being so lightweight, it means it's particularly suited for cladding. And of course, cladding is often the architectural expression of a building. It's where we spend a lot of our effort as architects. Not the only place, but it is a key part of the work that we do. So, I could put hundreds and hundreds of examples of beautiful different varieties of different textures and surfaces that are around. I think it's worth saying from an architectural point of view, it's not just cladding, of course, but the lightweight nature and the ability to achieve really good and varied finishes means that it's also probably more suitable to interior fit-outs and interior architecture than more traditional concrete, because it's easier to move around, you can maneuver it to move into additional spaces. But of course, it doesn't have to look like concrete, or GRC often isn't. Great examples of a brick-faced cladding, and of course, you can see some in the exhibition around the corner. So this is the ability to be able to embed other materials into the surface to give whatever type of expression you want. Maybe a little bit more of the sort of historical or vernacular style if it's needed, or whichever vernacular style, depending on where you are in the world and the sort of expression that you're after. But that expression isn't necessarily looking at vernacular, it's also forward-looking, looking at the expression that is facilitated by new manufacturing techniques. So graphic concrete, sort of digital images printed using retardant onto the surface. Some really lovely examples all over the world with regards to creating permanent pattern, permanent images, photographs even, within that concrete. Now, I talked about the lightness and the thinness, but that also gives it that, but this is what defines it very much from most ordinary concrete, is what I'm going to say, is the ability to provide open panels, so thin sections, the ability to have some light filigree in the design, and to incorporate open panels on facades. So many beautiful examples all over the world where you have the ability to provide not just the durability and the security, but also the sun shading, the views out, the ventilation. Excellent examples there. And that ability to embed holes or to create gaps within the surface used to great effect here as acoustic paneling on the inside of a building. So there's lots of, and actually, this is my segue into other types of, some of the other benefits with regards to architecture, is the ability of GRC to be able to take a form, to be curved, to have those beautiful double two-way curves that you see all over the Elizabeth line and other examples. And again, some other great shortlisted entries for the awards this year, whether it's a whole building showing all those beautiful curves and sinuous shapes on the surface, or giant vegetables, of course. It's hard to imagine how this could have been achieved in anything other than GRC. How would you lift it, for example? And some old favourites as well. So the ability for the creativity and the architectural expression is just extraordinary, and has so much potential, and is really key to some of the more contemporary changes within architecture, probably heralded by the ability that we have as designers to be able to design this much more easily using 3D imaging techniques and modeling and all of the different computer programs that enable us to envisage and design and control these curves, but also in the manufacturing and the ability for GRC to be able to embed digital technology in the making of these complex shapes. And I think I see that as a definite trend of going forward. It's certainly something that the GRC manufacturers have embraced. And they talk about digital fabrication as being the third industrial revolution. Now, whether is that architecture driving that or the other way around, they certainly go together. Off-site manufacture, for example, GRC, of course, is a modern method of construction. That's a terminology that's used within the UK. It'll be other terms elsewhere. But it's the benefits of that mechanized construction, reducing the amount of waste, being able to be manufactured off-site by skilled people within a factory rather than relying on-site. So lots of benefits there that obviously do inform architecture, and the two work together. So as I said, it's not just all about what it looks like, although I know that was a bit of my brief to be talking about today in terms of aesthetics. Of course, we need to think about the performance, we always do. These are some of the key considerations and benefits that are brought to buildings from GRC to varying degrees, and you'll need them to varying degrees in different types of buildings and uses. For the material. But what is key, and this is something where is the need of architecture evolving forward, is that do not be just thinking about what that performance can do for us today, but it's the performance of what it needs to do tomorrow and in the future. And we've all got to be thinking about designing for future weather conditions, future climate conditions. We know the world is changing already. Now that's not just in the architecture that we produce to respond to that, but that's also in making sure that the materials that we're making can cope with those changing weather conditions. They will be different in different parts of the world. In the UK, we're looking at warmer, wetter, more extreme flood events. We're already starting to see that. Going forward, we're going to need a few more of those beautiful filigree sunshades, aren't we? Because it's getting what we need to be embedding shading to reduce the risk of overheating in our buildings and around our urban environment. Biodiversity, we know that that's a threat. There's some great potential of being able to form concrete into shapes that actually can enhance and encourage growth. This is some great some tiles that have been trialled over in Wales using fibre reinforced concrete. It's ultra high performance concrete in that instance. But otherwise, different ways in which we can use the material to about encouraging plant growth, insect growth. Lots of great opportunities there. Now, this is being driven by many different factors. There's a push, there's a pull, there's legislation. Certainly resilience that I've talked about now is so important, it's embedded within the planning requirements of our within the UK, which means that you need to be able to demonstrate how you've designed for future proofing your buildings before you're enabled to go through planning. I'm sure that's going to be, if that's not in other parts of the world, it will be coming, I'm sure. But climate change considerations isn't, of course, just about making sure that our buildings are adaptable to mean that they're appropriate and useful for us to be able to live in and thrive within our built environment, but it's also about limiting the impacts going forward. So that's about mitigation. And most of the time when we're talking about reducing the impacts of climate change and mitigation, we're talking about greenhouse gas emissions, and we're talking about embodied carbon, or carbon within the buildings, or whole life carbon. And from a GRC point of view, cement is one of the key issues. You may see this figure. I see it a lot within the concrete industry. Globally, cement contributes around 7 to 8% of the emissions. Those figures vary according to where you read it, but this is fairly well understood. Now, in a way, it's not surprising because there is so much of it used. After water, it's the most used thing on the planet. So you would expect that. But that's not an excuse for it. It means that we need to be looking at it. Do we need to be using quite so much? But what we all need to be doing is making sure that the carbon associated with its manufacture is reduced. And that's something that hopefully that you're all aware of. I know there's been a lot of talk about it within this conference. Now, the good thing is there is a plan. There's lots of plans. The Global Concrete Cement Association produced a route map for how to get to 2050 using decarbonising without offsetting. If you're not aware of that, please do look at it. Well, it's a mammoth task to bring together all of those international members and all of the different commitments that are being made and being developed in different member companies. People are on different stages of the journey. In the UK, we've been doing all right. We've been decarbonising for many decades already, the cement industry and the cement and concrete industry. In fact, the carbon footprint of cement in the UK is 53% lower than it was in 1990. But there's still a lot to do, and it's going to require a lot of international collaboration. And so, and you can't wait. You can't just say, well, the cement's decarbonising, so I haven't got a problem. You need to be thinking about all the different materials that you're using, because increasingly, and I'm sure this is already happening, you're being asked for the credentials and the carbon credentials of your materials, because we as architects are being asked to do that, and we're wanting to do that, to be able to drive down those carbon emissions. There's lots of ways to do that. There's no silver bullet. The industry has identified a whole range of different ways in which it can happen. And that's, if you're interested in what's been happening within the UK, these are two key documents, our most recent documents, that you can download to have a read. In the longer term, a lot of it is going to be about carbon capture, and that's where the most investment is needed, where the most help is needed. Norway is set to be the first up and running carbon capture facility in the UK. In the world, we're running for a close second within the UK with HyNet, I'm pleased to say. There is a lot of work going on to look at deploying different technologies and ways in which that can happen. But we need to work out what to do right now as well. So understanding what our carbon footprint is and understanding and what can we do better. And that's what we're now doing as architects, very much in the UK. When I first started the Concrete Centre, which was about 15 years ago, most of my questions were all about, Elaine, how can I make concrete look good? How can I make GRC look good? Now, and I would tell them, but also add in a bit of sustainability guidance in there. But there generally wasn't a big pull for wanting that information. It's now completely flipped. And architects are asking, what is the sustainability credentials of the concrete? How can I use it to reduce the carbon footprint of the buildings that I'm designing? What are the implications? It's right up there. Now, a lot of the work that we're doing within the UK is to do with standards, and there are many challenges and barriers and things, and there's lots of opportunities as well. But it's worth understanding that cement isn't just Portland cement. There are many other types of cementitious materials out there. There is a huge amount of innovation going on to look at what other ones are available, what are the lower carbon options are, or what can we combine with Portland cement to actually reduce the carbon footprint. So and this is a change that's about to come out this year in the UK, which is greater use of limestone in combination with other byproduct materials like fly ash or GGBS to reduce the carbon footprint. There's lots of different things happening, and I would be expecting, and architects will be expecting manufacturers to be stepping up to this to understand that. Now, to understand that, it's about measuring your own carbon footprint, not just your carbon footprint, but all your environmental impacts. It's not until you measure, do you know where they are, and then you can actually start reducing. So hugely important. Good thing to know, and you've already had a great talk by John earlier on in the week, I understand, with regards to what's on the GRCA website. A good thing to understand is that the cement industry, we've been doing this for a little while now. All of our members have the ability to get some discounted tools to produce EPDs. There are 2 average cement EPDs for cement in the UK. So immediately you've got the figures to know what to put into there. Or if you know who your manufacturer are, the chances are that cement manufacturer has its own average EPD as well. And there will be international ones out there, and more are coming through. Now, there's a lot of jargon to understand, not jargon, but terminology, and it's changing all the time. I just put this slide up just in case, I'm going to be talking quite a lot about embodied carbon, but actually, of course, whole life carbon is the real thing. That's the measure of a material right from its inception all the way through its use stages through to the end of life. Those are all added together to measure a building or a structure's whole life carbon life cycle analysis. Now, it's really important that that whole building is looked at, because obviously a building is some of its parts, but sometimes we can look in silos, and we need to be careful about that, because of course lighter cladding can lead to a leaner structure, which means you might be able to reduce the carbon footprint of the structure that you're supporting and the substructure that's there. Moving forward, even the structure could become more lean in itself. Now, this resource efficiency is fundamental to another driver and key change of what the built environment is moving towards, and that's resource efficiency, or the circular economy. And this is about reducing the amount of stuff that we use, reducing the amount of waste that we produce, repurposing what we have, recycling at the end. And this is a sort of mantra, if you like, that we're starting to apply to buildings because of the recognized need to move more towards a circular economy. This has started off very much within the textile industry and bags and consumerism, but it's really within the UK, certainly, it's really starting to come through from a circular economy point of view. Our colleagues in the Netherlands and Denmark, I think, are probably a little bit further ahead than we are. Now, one of the key things, if you're not aware of circular economy, there's lots of guidance that you can find on our website, and in fact, a lot of what we do is focused on trying to give sustainability training to the industry to understand. It's about longevity to some extent as well, making sure that what we've got we can use and reuse for as long as possible, maximising that. And of course, great examples. We know GRC can last a long time. It has a long life potential. It also, throughout its life, requires little maintenance. So those adding up together all are really unique to, concrete material. Has a different profile. And this is starting to come through in legislation. If you're doing a major scheme within London, you have to put a circular economy statement together and submit that as part of your planning application. It's embedded within sustainability assessment like LEED and BREEAM, and then also other organisations who are setting carbon targets have recognised that circular economy is a key way of achieving carbon targets as well, so people like Letty and Reba. Now, the circular economy can be quite complex. There's lots of different ways in which that's achieved, but building in layers is one of those core principles. And what that means is that it's matching the anticipated life cycle of the materials that you're putting in with how long they're likely to be able to be used within that building or elsewhere. And of course, from a GRC point of view in a cladding, it has a potential for long life. Is that going to stay there? Or actually, got that great potential that cladding can be unbolted, taken off, and used elsewhere. So architecture is increasingly looking at what is going to happen to our buildings at the end of its life. And that means that from a manufacturing point of view, we need to be understanding that, recognizing that, thinking about it. Now, end of life can be reused because, of course, you've got that long life, but actually then there's the very end of life. What happens there? Typically, it's going to be crushed up and used. But are there any implications of that? Are there better uses for this? Actually, there's a lot of manoeuvring, looking at crushing up concrete to a very, very fine paste, and they'll be able to recycle the cementitious properties of that. But then how do we extract the fibres? These sorts of questions are what architecture is now starting to embed in its thinking and is impacting on material choices within the built environment, certainly within the UK. And of course, then that whole ability of keeping that structure up and then taking the cladding off perhaps is another real opportunity, because this is one of our other key challenges. It's about improving the housing stock, improving the efficiency of the buildings that we have today. And I think GRC has got a real potential of being able to create all of those, bring all those benefits that I've talked about in terms of the long life, the durability, the fire resistance, the beautiful facades, to be able to improve the energy efficiency by overcladding and recladding existing buildings. Now, I have talked a lot about carbon. Sustainability, of course, isn't just about carbon. It's about very many other factors, and these are going to be different in other parts of the world depending on what your pressures are. Is there water shortages, access to minerals, all of those things, responsible sourcing, ethical manufacturer. There's a whole wealth of things that we are all increasingly starting to think about. And GRC has a real potential to be able to help facilitate that sort of environment. And I thought I would end with where I started today, which is actually travelling down that escalator to come here today, but it seemed a fitting slide to end on. Thank you very much.